Let us see the next problem. The problem is given like this. With the question, determine the reaction at A and B of the overhanging beam shown in the figure. So you can see that at this portion there is a support, at this portion there is a support, and this portion is overhanged. So it is, and the entire beam AC is overhanging beam. The portion which is overhanging is BC. So here this is a figure where one moment is given at a point D, one inclined load, one UDL is given, and here the support is represented like this. So this is hinge support and this is roller support. Once you have the question, the first thing you check out whether it is named with all the variables at the points of loads, if it is UDL at the end and starting point of the UDL, and check whether it is named with any variable at the support points. So support is here which is named as A, support is here which is named as B, and UDL starting B ending C, and inclined load it is E, and moment at it D. So everything variable is named. So if once a variable is named, then you extend the lines. Draw the beam where this point is C, this is B, this is E, and this is D, E. Once the variable is written, the values of the distance between the variables you write as it is in the question. And next, the load which is point load you have to write as it is. So this is a moment, this is a inclined point load. Now it is not a vertical point load. If it is an inclined point load, you have to resolve the force. Since the arrow mark is like this, one component will be like this and the component will be like this. So this will be downwards with the 30 sine 30 degree. This will be 30 cos 30 degree. So this is a resolution of inclined force. Then this is a UDL. So you have to write the point load as it is, and as well as if there is any moment, you write the moment as it is at the point. So it is acting at D. Moment is acting in a clockwise manner with the value of 40 kilonewton meter. So you write the point load as well as moment as it is. Next, if any other load, that is UVL and UDL, you convert it as a point load. So it is having a UDL of intensity 20 kilonewton per meter. So the point load is at the middle with the intensity, that is area of the rectangle, 20 kilonewton per meter into 2 meter. Meter and meter get cancelled, so it is 4 kilonewton. Sorry. So it is 40 kilonewton. So this is the intensity, and it will be at a distance. Since this whole distance is 2 meter, it is acting at the middle. So at a distance of 1 meter and 1 meter from the either point B and C. Once loads are converted into point load or moment, then you have to see the supports. Here there is a support and it is a hinge support. So the reaction will be two reaction. One is horizontal, one is vertical. So I'll take this one as RAY and RAX, and at point B there is a roller, only one vertical reaction, that I'll take it as RB. So now the free body diagram is done. Apply the conditions. Sigma H is equal to 0. Check all the forces that is traveling horizontally. One, that is plus RA x, since it is towards positive x-axis. Next there is one more force here, that is towards negative x-axis, so minus 30 cos 30 is equal to 0. So Rax is equal to positive value, so the assumption whichever we have taken it is correct. So it is 25.98 kilonewton, or else you can take it as approximately equal to 26 kilonewton. Next we apply the second condition. Take all the vertical forces, it is plus Ray. Then here the moment is not a force, so you need not consider for sigma h or sigma v here, since it is a moment. Where you are taking the moment, at that time you can take this moment or a couple. Next at point E there is downwards 30 sine 30. Next upwards plus RB, downwards 40 kilonewton, which will give you a equation Ray plus RB is equal to 55 kilonewton. This is equation 1. Next we apply sigma m is equal to 0 at any point, that is at A or B, wherever the support is present. So I'll take at A, so Rax and Ray creates moment equal to 0. Next, do not leave this moment now, since we are taking moment or couple which is a product of any one of the force and the perpendicular distance between the two equal, opposite, parallel forces. So either I can call it as a couple or a moment of a force. So whenever I am taking a moment equal to 0, I have to take this moment which is given in the figure as it is. So it is a clockwise moment plus 40. So it is better to take first all the moments that is present in the beam. Here there is only one moment which is given directly, but there will be chances that you might leave this moment in a hurry to write the equation. So it is better, while taking the moment, it is better to once again check the question or free body diagram whether there is a moment given there. If moment is given, first you write the moment depending on whether it is clockwise or anti-clockwise. Now it is clockwise, so it will be positive 40. Next move on to point E, where there is a downwards 30 sine 30 degree, which will create a clockwise moment of force into perpendicular distance. What is the perpendicular distance? Point taken is this one, so drop the perpendicular to the line of action of the force. So it will be 3 plus 2, that is 5 meter. Next, this horizontal force doesn't create any moment, again moment equal to 0. Next, RB. RB creates a anti-clockwise effect of a moment with the value of force, that is RB, you need to calculate, into perpendicular distance is from this point till this point, that is 3 plus 2 plus 1, that is nothing but equal to 6 meter. Next, one more force that is acting here of magnitude 40 kilonewton, which is downwards, so it is creating positive, that is clockwise moment with the force into perpendicular distances. See here it is a UDL, so the line of action is somewhere here and you have to drop the perpendicular from this point till this point. So it is from here to here is a perpendicular distance, that is 3 plus 2 plus 1 plus this much value, that is 1 meter. So 2 plus 2, 4 plus 7. So into 7, that is equal to 0. Check whether any other forces are there. I think we have covered all the forces and moments here. Next, you calculate, since only one unknown, you can calculate RB. RB is equal to 65.83 kilonewton. As per equation 1, RAY is equal to, you will get it as 55 minus 65.83 kilonewton, which will be equal to minus 10.83 kilonewton. See, this minus value of RAY says that this reaction which is upwards is not in upwards manner, but it is downward in manner. So once again you can draw the free body diagram and show the direction as downwards, or else you can write the value as minus 10.83 kilonewton. So this is a solution for your figure which is given here. So the difference between the previous problems and this one is, here there is a moment which is given in the beam itself. So this moment doesn't come into picture while you are taking sigma h and sigma v is equal to 0, because it is not a force. It may be a moment of a force or a moment of a couple. That is why we are not taking in consideration. This will be directly taken into consideration with its effect in sigma m is equal to 0. That you have to remember. So do not leave this one while taking sigma m is equal to 0.